So after connecting everything, you have a triangular run button here. So if you click that, it will immediately you'll get the value for V and I here. So I'm just clicking on the run button. You see what value you are getting. What is the voltage value as you see in the diagram? Maybe I'll magnify it. What is the voltage value you see?
12.07.
Yes, it is same as 24 by 2, right? So 24 by 2 is 12. Theoretically, we got exactly 12, but practically, because of all the parameters what we consider, it will be slightly either less or more than half the value. So 24 by 2 is 12. We are getting 12.07. And what was the value of IC we got in the problem? You remember the value of IC we got? Maximum
1.25.
value of IC, yeah, maximum value we got as 3 milliamperes. So 3 by 2 should be 1.5. We are getting 1.49 milliamperes. So can I say this transistor is running in active region? Can I conclude that this transistor is working in active region? Yes. How do we say that? Because, because what is, how do we conclude that the transistor is working in the active region?
Q point is at the center.
Yes, because the Q point has voltage exactly half of the VCC and current is also exactly half of VCC. See how simple live simulation has become in this software. So you can simulate any circuit using this software. It will, constructing this circuit will hardly take 1 minute, and getting the value of V and I will hardly take few seconds. See, I clicked the run button, immediately I got the answer. And you can change the values also and see, instead of 24, if I give 20, you can see what is the value. See, I'm getting 10 and 1.2. So live, you can change the values and see. If I'm giving 10 volt, what is the voltage and current? You can see the values live. You need not stop the simulation and change the value. You can see the values live. If you change the value, automatically the parameters what you measure will be adjusted accordingly. So this makes the software very, very interactive. So I request all of you to create a login and start exploring these softwares. Electronics is fun. So more and more you construct these software, construct these circuits and analyze the behavior, finally a project will become very, very simple for you. So before you are building a circuit, first you have to simulate and see whether the circuit is functioning or not, right? So for that, all these softwares are very, very helpful. So this, I think, should give you a real feel of how a biasing circuit will look like. So only when you conclude that the VCE and IC values are exactly half of the maximum permissible values, you can say that the transistor is working in the active region. Otherwise, you can say that the transistor is either moving towards saturation or it is moving towards cutoff region. So I have already sent the Multisim software link in Google Classroom. So try logging into the software and you can simulate the same circuit and see whether for 24 volt we are getting, we see the Q point value as 12 volt and 1 milliampere. Sorry, 1.5 milliamperes. So you can cross check that by yourself also.